Okay, so problem number 2 states from the figure shown, determine the smallest force P regarding the 30 kilogram block moving if cable AB. First case, if AB is attached to the figure shown, or if AB is removed. The coefficient of static friction is 0.3 between all surfaces of contact. Please draw all necessary free body diagram. So we know that mu s will be equal to 0.3. And then here, it tells us to consider two cases. First case is if AB is attached. Second case is AB is removed. What does that mean? So if AB is attached to this wall, this pulley right here, that means that you were pulling those two things at the same time. It means that not just this 30 kilogram object will move, will slide, but this 20 kilogram object will also move as well. So it means that you have two friction. One is the friction between those two surfaces, and the other is the friction between this 30 kilogram object with the ground. But if cable AB is removed, what does that mean? That means that the force P is going to put this object, and then this 20 kilogram object is not going to move because it's going to stay steady on top of 30 kilogram object. So it will only have one force, which is the force between this 30 kilogram object with the ground. Okay, I'm going to draw the free body diagram so you guys can understand it better. So let's do A. So A is when cable AB is attached. And then we know that for this case, we have two friction forces. Okay, let's draw a free body diagram. So free body diagram for the 20 kilogram object. So we know that the weight is so 20 is the mass. So weight is gonna be mg, and then we know that there will be a force, let's call it T, pulling this thing to the right, and then also the friction is going to be opposite of the pulling force. So right here, so this will be F, and let's call this F1. Okay. If we and also here's the normal force. Let's call it N. Normal force N. But we know that normal force is going to equal to mg because they are balancing out. Okay. Also, when you do the force in the y direction, you can see that the mg is equal to N. Okay. Right now, let's do the force summation of force in the x direction. In the x direction, we know that T is equal to frictional force 1. And then we know that because since we always want for frictional, for friction problem, we always want to consider slipping first, then tipping. For slipping, we mean that we assume that the F frictional force is going to be equal to the mu s multiplied by the normal force. So F1 is going to be mu s multiplied by N. Then mu s right here is 0.3, and N is the mg, which is going to be 20 multiplied by 9.8. Okay, then we get T is equal to F, and that'll be equal to, let me see. And that'll be equal to 58.86 newtons. Okay, so that's for the first case. So we determine the tension and the frictional force of this thing. But since P is pulling at the 30 kilograms, so after we determine those two parameters, then we have to go to another free body diagram. I have to draw the 30 kilogram free body diagram out and then determine what's the P. Okay. This P is 20 kilogram, 30 kilogram. And then here's the frictional force F. and here's the tensional force T, and then here's the frictional force F. Let's call this F2. Okay, and how do I know friction is going um, in this direction? That's because that think about it. In this case right here, the pulling force is T, right? So the force has so the friction has to be opposite of that. But in this case, the pulling force is the P. Okay, so the frictional force has to be opposite of P. Okay. And then let's do our summation of force in the x direction. So in the x direction, I have negative P plus F1 plus F2 plus T equal to 0. And since I know that F1 and P, they're equal to each other, so I just need to figure out what F2 is. Okay, and F2, that's going to be, like I said, that's mu s n. And what's the n in this case? N will be different. So F2, that's on the bottom. So F2 is right here. So n for F2 be equal to m1 plus m2 multiplied by the gravity. So because F2 is on the bottom, so the weight exerted, it will be the combination of these two weights. Okay, so that's why for F2 you have to consider both weight. F2 will be equal to, so F1 is 20, M1 is 20, M2 is 30, 9.81. Sorry, is multiplied by 50, 9.1. So you get 7.15 newtons. Okay, and then plug this back into here. So we get T equal to F1 plus F2 plus T. And F1 that's 58.86, F2 that's 147.15, and T that is also 58.86 newton. The minimum force that required to put this thing, I got 264.87 newtons. And so that's the answer for part A. That's when cable AB is attached. But when cable AB is not attached, let's see that. That's when AB is removed. And for that, we only have one frictional force. How? Let me show you guys. It's 20 kilograms, 30 kilograms. Okay, we still have this force P right here pulling at this thing, but at this time we don't have a tensional force T that's resisting the object back. So in this case, we don't have one force, which is a one frictional force, which is the F. That's also in this direction. Let's just call it F. All right. Like I said, we know that N is going to be M1 plus M2. And then just have to do summation of force in the X direction. In the X direction, you know that P is equal to F. So how much you put in it is how much this thing's resisting. So F, we know that is equal to mu S multiplied by M1 plus M2 multiplied by the gravity constant. That will be equal to 0.3 multiplied by 50 multiplied by 9.81. And we get P will be equal to 147.15. Okay. All right. So let me explain this over again. So when cable AB is attached, when they're attached, it requires you to have 264.87 newtons. It requires to put this much force in order for these two things to move. But when cable AB is not there, it only requires you to exert 147.15 newtons of force to put this thing. It's reasonable, right? Because this tensional force right here is resisting you to pulling it back. So it requires you to have to exert more force on it in order for those two objects to move if they're attached, if there's cable AB that's resisting. All right, that's all for problem number 2. I'll see you guys in problem number